All right. Hello and welcome to another lunchtime session for the Azure user group here in Copenhagen. So my name is Morten. I'm one of the organizers of the user group, and this is where you can find us. Hopefully you are watching on YouTube right now, so you already know where to find the stream. You can find us on Twitter and on Meetup as well. So for today's meetup, we have Henry joining us to talk about logging, instrumentation, dashboards, alerts, and all of that jazz, I guess. So welcome, Henry,
Thank
to
you.
the stream. Great to have you with us today. Thanks
It's
for
very nice.
taking time out during your lunch hour to teach us about logging and instrumentation in Azure.
It's very cool to be here. So thank you for the invitation, I guess.
Yeah. Well, so I think we should just kind of get into it. I think people are here to hear your talk. So I'll just remove these slides from the stream and then add your slides to it. And then we can just get started. And to everyone watching, please feel free to post your questions and comments in the chat, and then we'll take it throughout the stream. But with that, let's just hand it over to you, Henry. Please feel free to take it away.
Thank you very much. Good afternoon, everybody. My name is Henry Bain. I am a developer and architect from the Netherlands. I actually live on a range of one of the islands that we share with Germany and Denmark. I live on Texel, the far western of what we call the Waddeneilanden here in the Netherlands. So hopefully that gives us a little bit of a link. Today, I will be talking to you about logging and monitoring from the standpoint as being a developer. So I am not an operational expert. I haven't been, using all kinds of tools and an expert on those. My point of view is that I am a developer and that I transitioned from just writing code into somebody that also had to take on some operational responsibilities in a team, monitoring our applications, or at least giving others the tools they need to effectively monitor the applications that I have been working on. So from that perspective, I want to share with you what I have learned today. My contact details are on the screen. If you have any questions or comments, feel free to reach out during the session, but I will have to respond after the session. And I will repeat those on the last slide so that you can reach out to me if you want to. So what we will be doing in the next 55 minutes or so is talking about three different things. I want to discuss with you a little bit of monitoring theory, things that I've learned. Then I want to talk with you a little bit about what to monitor. I think when you get into monitoring applications, it is very tempting to start monitoring all kinds of things because it feels smart or it feels like something you have to do because everybody else does it. But that's not necessarily where you want to start. So I also want to share with you thoughts on that topic. And then finally, I hope that we have a good share of time left to look into Azure and see how you can implement monitoring and logging when you're running your applications on Azure. All right, starting with monitoring. And I think this is the essence of what I will be talking about. And you will hopefully see that throughout the talk. Monitoring is knowing what is happening. It is not about fancy graphs. It is not about logbooks or log streams or things you must do. It is about observability. It is about knowing enough about your application in production environment to be sure that it is satisfying your customers' needs or your users' needs. That's for me the essence of monitoring. To do that, there are three different tools in our toolbox. The first one is instrumentation, the art of getting numbers out of your application. It's a thing that we start focusing on often when we get into monitoring. Things like the amount of the percentage of CPU in use, the amount of free memory, how much disk space there is left, those kind of numbers. But it can also be numbers that we get more out of our application code instead of just the infrastructure that we run on. The number of currently logged in users, the number of times a customer puts an item into a basket. The infamous story, and I don't know if it's true, but it's an infamous story that Netflix only has one very important metric: the number of times somebody presses play. If that number drops, something is going on. that number increases, something is going on. Apparently, as story goes, it is a very important metric to them. When we talk about metrics, we can of course use them to get percentages of something or count things. We can also use them to register events. For example, if we want to count how often somebody uses a wrong password, we can emit that as a metric with a value of 1. And when we count those, we can get the number of events out of it. If you come from a background more in for operational technology, you might recognize metrics as a time series insights. And that means that they can be stored in very specific databases, sometimes called historians, or other databases that are optimized for time series insights. Now, metrics generate a lot of data. So one of the things that you want to do is roll the data up over time. Not every system supports it, but if you measure the amount of memory in use every second, that's going to give you 3,600 data points every hour. If you want to retain that for, let's say, 3 years, that's a lot of data. Now, knowing your CPU usage for the last 5 minutes in very much detail helps you to understand how the system is loaded. Knowing that amount of detail is not necessary for 2 years ago. For 2 years ago, you maybe want to have the average for every half hour and the minimum and the maximum so that you can look at trends. So this, slowly degrading the precision of the data, we call rolling up over time. And the final thing that you should know is that we can add dimensions to metrics. For example, instead of just measuring the temperature in my house, I can add a property to the measurement called location, and then add separate measurements for all the rooms in my house. Using this type of thing, dimensions, instead of having separate metrics, allows for very quickly getting the average over all temperatures, but also looking at the temperature in specific rooms. And we will see this in practice later on. The second thing that we use a lot is tracing, or what we developers tend to call logging. It is concerned with getting information out of our system about which code is running when and why, and sometimes even the values of certain variables. It's the thing that you do when you start learning a program. It's writing to the console, but once applications start growing, you want to use a logging framework. When metrics generate a lot of data, this generates humongous amounts of data. So one of the things you often do is retain this information for a very short period of time, 2 weeks, 1 month. Even if a bug hasn't occurred in the last month, so you can't find anything in the logs about it, it's probably not worth fixing anyway. The bugs that you really want to fix are the bugs that recur several times a day or maybe several times an hour. But it's very system oriented, I think, and that's an important thing to know because that separates it from the final thing, which is what the theory calls logging, and we developers tend to call auditing or audit logging. It is concerned with recording a set of state changes in your system, things that are important to the business, not system oriented, but user oriented. Who does what and when? This is the place where you go if you want to prove to me that I was the person that ordered 37 pizzas instead of 3. This is where you go if you want to prove that I paid 10 euros instead of 100 euros for something. It is also the thing that you, for example, use when you find a compromised account and want to find out what has happened with that account in the last year. Often this data is retained for a much longer period of time or even indefinitely. Now, these two are often intermixed, and you can use the same technical means to fulfill both needs. But this, difference in retention time makes that you might want to have a look and make sure that you do not keep your tracing information too long, but do keep your logging long enough. Now, both tracing and logging can also be a source of metrics because we can record how many warnings our system generates, or how many errors, or how many log messages in total. And that in itself can be interesting information. We will be seeing all the first two, so instrumentation and tracing, in the demos later today. Now, at this point, you might think, hey, that's tough. It's not for me. I'm a developer. I just write applications and I throw them over the wall. Why would I care? And I think that's an attitude a lot of young developers start out with. However, if you want to be cool, you got to get on the DevOps bandwagon. And I think knowing about operational things is a skill that's more and more asked of developers. But I don't think that's enough motivation. You should also look behind the why this ask is getting there and why you should know about operational things. So if we look deeper at DevOps beyond being cool and happening, it is a philosophy that looks at how we create software. We look at a combination of people, process, and products to continuously deliver value to our end users. And to make that possible, one of the most important things is that developers and operators start working closely together to continuously ship new updates in a way that keeps stability. So you don't compete, you work together to stably release new software. Now, to work together with somebody, you need to know, at least to some extent, what they are doing, to have good conversations about what they need or about what they're going to do today and what they need from you. Also, there is very little to monitor about an application or operate about an application if your code does not emit metrics or log entries. So you really got to work together, and for that you need to know at least enough to give them the things they need to do their work. Or maybe you're even adopting a no-ops philosophy and you say, we don't have people specifically for operational duties. The developers do that as well. And in that case, you really need to know about this stuff. Okay, so kind of assuming that you can now care and you really want to learn more about monitoring applications, the next question that probably comes up is, what should I monitor about my applications? And like any question, a good approach is pick it up, twist it around, and maybe also take a look about what not to monitor, because sometimes that can be not only fun but valuable as well. And I think the first thing that you might not want to monitor is your systems. When I started out as a developer, and it was a while later, we got our first operator in the team. And what the first thing he did was, getting all the systems in the monitoring. He went to all the VMs, installed an agent, and started gathering all kinds of metrics. The average amount of CPU, how much memory there was free disk space, the average response time of APIs was automatically gathered. And so we got a lot of graphs and we got a lot of insight into how the infrastructure was operating. However, going back to what I believe monitoring should be about, are my users happy? That's a very difficult question to answer when you know the average CPU usage. My users don't really care about page file size, for example, and the amount of disk I/O doesn't really tell me anything about whether customers are buying stuff or not. So just focusing on your systems is not necessarily a good tactic. And the other one is focusing on averages. What I also saw was that we had a lot of dashboards showing the average of this and the average of that. And one thing that we found was that the average response time of an API was always 45 milliseconds. No matter what, more or less 45 milliseconds. So apparently it's not a very useful metric. When we started plotting other things, like for example, the fastest response time or the slowest response time in the same graph, we saw that those things were much better indicators of the load on the system or how the system was behaving. And minimum and maximum is quite extreme. So you can, for example, also use the 5/5 percentile or the 95 percentile measurements. Now, to add some nuance, is it a complete waste to monitor your systems? No, it is not. And is it a complete waste to have dashboards that show you average response times? No, they're not. Because trust me, when your available file size is approaching 0, your system is going to stop running at some point. So monitoring the health of your systems is valuable. And the same goes for averages. If an average spikes up, it's probably something going wrong. Just don't overly focus on them, if you ask me. Let's take a very quick look at the chat to see what's happening there. Is there any questions?
It's mostly a comment related to one of your previous slides.
All right. Okay. Then the comments I will defend myself later on. All right. So to put that a little bit in practice, this is a story from a company where I worked a while ago. And we had thousands of databases at the company, and all of those databases were designated to work for just one specific user. And all the databases were having a load of, somewhere between 5 and 25% all the time. It was just a given. We didn't really monitor it at all because, everything was working fine. Until at some point, kind of by accident, an operator noticed that a database did this. The load spiked up to 100%, stayed there for a few minutes, and then spiked down to, the regular load. Now, at that point, the operator said, what we need to do is we need to add an alert whenever a database goes above 80% load. We need to scale it up. And true story, I said, no, we don't. Instead, we need to celebrate. Instead of paying too much for capacity we don't need, we're finally using the capacity that we're paying for. Now, as you might imagine, that comment didn't go down very, very well. So we had a discussion about what to do. And the decision that we made was to ask the customer what was happening or if the customer was experiencing any issues. Now, what we found out was that the user came into the office, get the sleep out of his eyes and, longing for coffee, but, he was there just on time. So what did he do? He put on a very, very hefty report that took a few minutes to generate. He actually enjoyed that because it gave him time to walk to the coffee machine. And whenever somebody commented, he could say, well, I'm just running this report. I'm getting a coffee while I wait. So my theory is that if we gave the user more performance, it would cost us more money and the user would be less satisfied. Now, of course, this is a very funny story and it's almost completely true, but it doesn't hold in all cases. The point that I'm trying to make is really understand how the behavior of your systems is impacting your user before making decisions, and especially before spending money. So really measure things the user cares about instead of, metrics that are easy to grasp. And another famous example is when you have a producer-consumer pattern in your application. You have some API that gets work submitted to it, puts it on the queue, then you have another thing processing the work. One of the things that people often start monitoring is the number of messages waiting on the queue. If it's 10 or 100 or 1,000, and then, alert at a certain level. But it doesn't really tell you anything, because if you have 10 messages on the queue and you're processing only one an hour, that's not a very cool delay for the last one. That's 10 hours. But if you have 100 messages and you process 10,000 messages a second, it's probably not a problem. So really think this through. And it's not as easy as you might think. Now, I found this out the hard way. And when I was, diving into this topic more and more, I stumbled upon this book. It's written by Mike Julian called Practical Monitoring. And he reiterates a number of these points as well. And also, gives you a bit of starters where to get started. If you don't like reading, it's also quite thin. So that's a plus as well. I can highly recommend it. Now, all this theory, I'm hoping you're sticking along. And how would you do this on Azure? So you're building your web API, you're pushing it into an app service. How would you monitor it? So that's the final thing that I want to talk about for a little bit, and then just dive into demos and hopefully show you how it's done. In Azure, you have a pretty typical setup for monitoring. You have an instance of your application, being it a web API in an app service or a function in a function app, can be a container in container instances, any kind of application instance. It runs on something. Can be a VM, can be a container, can be an application host like Azure Functions, but it has to run on something. Now, if we want to start monitoring that thing, we need to do two things. We need to have an agent running on the platform that our application runs on as well, to gather the kind of default things like network usage, page file, memory, CPU, the things that are not application specific. You install the agent and you get them. It's not a lot of work, and it's also the reason that a lot of people start there. But the real magic starts happening when you also install an SDK in your own application and start emitting your own application specific metrics. Things like the number of times a customer puts something in the basket or completes a sale, those kind of metrics. Log messages, I'm now here, I'm now here. Oh no, this shouldn't happen. Boom, throw exception. That kind of stuff. Now, no matter which one you're using, your application host is probably pretty volatile. That's also a difference from a few years back. We just stored the logs on the machine, and if we needed them, we went onto the machine, downloaded them, and did our research. But now machines come and go. They come up, they run for half an hour, and then we don't need the capacity anymore, so they're destroyed. Or maybe we move our pod to another host because there is an update on the host, so we need to shut it down. They are moving around. So the best way to get our information stored somewhere is over HTTPS, send it to some endpoint, and from there store it in a specific database. And we will be using two different types of databases. You will have a logging database. That's a database that is optimized for things like full text search, high volume, append only often, and ingestion where the adding of records often correlates with the time that they're being added. Now you can have a query engine, and then you can get the log information out of it. Pretty similar to a database that you might know, just optimized for this specific scenario. The other thing is that you're going to need a time series database. That's a database that is optimized for storing tuples of timestamp value or timestamp dimensions collection value. You can query them as well, and the result will be very big tables. And as people in suits do not like looking at big tables, instead of just using a query engine, you're often going to use a visualization engine against such a database. And the query results that you get will be graphs, and you will combine them into dashboards. So you will approach that data in a different way. Now, that's all about storing it and querying it whenever you have a need or a question that you want answered. There is also another thing that we need out of our systems. We want to get notified whenever something goes south. So what you also get is that whenever the data is ingested by your HTTP endpoint, it is automatically forwarded to a streaming data engine where your alerts are defined, and all the data that comes in is constantly evaluated to see if your alerting condition is met. And the difference between the streaming data engine and a regular database is that a regular database stores the data, and you go to the database with the query, while a streaming data engine stores the queries, and the data comes to it, it evaluates the query using the data, and then it forgets about the data. So a streaming data is often, more memory intensive, but less disk intensive. It has different characteristics, which is why it's often built separately. And you can do that not just for time series, but also for logging in Azure. If you want to do this in Azure, you're going to be using these three services: Application Insights, Log Analytics, and the Azure Monitor. And I think a year and a half ago, they were reshuffled a little bit. And now we have one service called Azure Monitor, in which we have the two different things called Log Analytics and Application Insights. Now, Log Analytics, you should look at that as being the big fat database that can store both metrics, text and metrics. Azure Monitor also has a specialized data store for time series information along with it. And you have Application Insights along with it that you can use to get information out of your application hosts and out of your own applications, and it stores the data in Log Analytics. In the past, Application Insights had its own log store and could optionally be connected to a Log Analytics to store the data there. This is now the default, and the old pattern will be discontinued, I think in 2024-ish, give or take a year. All right, let's take a look at how to do this. And at this point, questions are very welcome to guide the tour. Now, before I dive in, let me show you this table very quickly. We will be looking at both logs and metrics in this demo. And we will be looking at them kind of in three layers. The bottom layer is the infrastructure, when I get a Cosmos DB or when I get a SQL database, how I can get logs or metrics out of those. Then we will be looking at application generic stuff, memory, CPU, those kind of things. And finally, we will be looking at application-specific things like my own logs and my own metrics. All right, that being said, let's start a proper tool like Visual Studio. Now, let's do this the other way around. Let's start by opening my browser here. I've prepared a little demo for you. It's going to be an API that you can use to store to-dos. It has a load generator attached on one end, and on the other end, it is storing its data in Cosmos DB. Now let's use that Cosmos DB to take a look at how we can get logs out of the infrastructural components within Azure. If I go to my customers DB resource right here, you will see that it's a service that I cannot really look into it. It's operated as a PaaS component by Microsoft Azure. But yet I might be interested in some of the things that happen within that service. Now, almost all services in Azure nowadays expose something what is called the diagnostic settings. The diagnostic settings, and then you get some weird commercial thing that I'm just going to click away. You will see that a couple of times today. Under diagnostic settings, I can say, hey, I want to send information about these things happening in the Customers DB to this specific log analytics workspace. So, for example, for Customers DB, I can say whenever, for example, I want to get regular reports of how much of the partition key resource units I use. I want to get information about the queries and how long they take and how much I/O they generate, etc. I want to get a log whenever a query comes in. So this is a query log. And you can say, I want to get specifics out of Table API or Cassandra or whatever you will. A question comes in if this will be adding any overhead and consume more RUs. To the best of my knowledge, no, it does not. The payment model in this case will be that there is a lot of data being generated and sent to Log Analytics, and you will be paying for the ingestion into Log Analytics. Now, when I make these diagnostic settings, I can choose where to send the logs that are being generated. I can send them to a storage account. If you just want to have them and not really using them, or want to very cheaply store them, that's a good option. You can send them to an event hub. That's if you want to do automatic processing in some way. You can even send it to a partner solution. And I think there are things like Splunk here. But of course, I don't have any of those, so the list is empty for me. It can go to Sentinel as well, for example. But the thing that we're interested in right now is I can send them to a Log Analytics workspace. I select my Log Analytics workspace, and the logs will be sent there. So let's take a look at that Log Analytics workspace. I go back to the resources in my resource group again, and here I can find my Log Analytics workspace. You can create new ones by just giving it a name, and then it will create the container and the database behind it. Now I open up my Log Analytics workspace. There are a lot of things that I can do here, things specifically for VMs, things like exporting data. What I want to call your attention to is this thing called logs here. Because what we can see here is all the logs that are coming into Log Analytics. And every type of log entry has its own table. So what you see here are the tables. And the name of the table starts with an indication of where that log entry is coming from. For example, app stands for Application Insights, CDB, Customers DB, etc. So if I, for example, go and I want to see how my runtime statistics are, I type CDB, query, runtime statistics, take 10. So the pipe sign is used to concatenate operators, and with take I specify how many records I want. I get the results out of this table. And for example, one of the things that I can get here is the query text. So this one will show me all the queries that have run. And there is also another one that I can use, for example, to investigate how much resource units every query takes. Or I can use this one to investigate how my resource units are used per partition. The things that I get out of Customers DB are specific to Customers DB. If I enable diagnostic settings on the firewall, I will get firewall logs, for example, allowed or denied connections. When I enable it on a SQL DB, I can get again query logs, authentications. So it's really every resource gives its own diagnostic log entries. And depending on your use case, you can choose to enable it or to not enable it. Because one thing that you have to consider is that all the data being ingested in Log Analytics is going to cost you about €2.5 per gigabyte. And if you want to retain it for more than 30 days, it's going to cost you again. You can also see the cost forecasted right here. Do we have a question?
Yeah. So I guess that It kind of relates to what you're talking about now. As Alan asks, I take it you recommend enabling diagnostics, etc., for all Azure resources and send them to log analytics. I guess you kind of answered that, but with it depends, and how much money do you want to spend on it?
And yeah, I think so. This is a very good point for a Star Wars quote, which cannot, go unsaid in any presentation. Only a Civ deals in absolutes. It really depends on your context and the needs from your business. So if you, for example, have a legal requirement that you have to prove that there were no delete queries sent to a database, you can achieve that by enable query logging, and then you can prove that. But it's going to cost you. So you have to balance those two sides.
Yeah. So we have another thing related to payloads. I'm not sure if that fits in better around application insights, but it is related to log analytics. So it's, I guess, a three-parter. One thing I feel is missing in the Azure stack is payload logging. I have an API and I want to log payloads. This becomes difficult with log analytics due to limitations in size. And then we solve that using Elasticsearch, which has full text search. To create something similar, we would have to use blob storage and some kind of cognitive services, and there's no web portal. Like Kibana, what are your thoughts on this?
That's an interesting question. I have to admit, I have never tried to do payload logging in log analytics, so I don't know if there is a maximum size for a trace message that would get in the way. So I can't answer the question. And if you have another tool like Kibana or Elasticsearch, it feels like a better solution indeed than using, for example, blob storage.
Yeah.
And I see one other question coming in. If I have a Workspace-based App Insights instance, will the data automatically flow into the Analytics Workspace tables? Yes, it will. It will. So if you connect your your application insights to your log analytics, the data will be stored in log analytics. Application insights will just work as you know it from before that connection. But the advantage is that all the logs now being gathered in log analytics workspaces, and you can join things. Like, for example, if a certain firewall grant correlates with a successful user login, you don't want to submit it for deeper inspection. You can build rules like that by combining tables. That's one of the benefits.
Yeah. So we just had to the other one about payload logging. Did you write that it's 30 megabytes for custom tables? The limitation.
All right. Then I learned something as well today. Thank you very much. All right, switching. So this works for almost all the services in Azure, and especially if you work in a domain like healthcare or government, this is important because it allows you to prove certain things or generate audit logs when you need. Now you can also get metrics out of all the services within Azure. So let's, as an example, let's try Cosmos DB as well. Almost all the services have also another tab called metrics. What I can do here is I can basically draw lines on the canvas. I select a scope, which is going to be a resource that I'm interested in. As I'm already navigating from my Cosmos DB, this is pre-selected. Then I have to select a metric namespace. So spoiler alert, there's always one metric namespace per resource type, except for application insights. Then I select a metric that I'm interested in. For example, the normalized resource unit consumption. So how much load am I getting on my database? And then how I want to aggregate multiple points into one point on the graph. So in this case, I'm using the maximum, but I can also do the average. And then you will get a higher value for the maximum. This way I can, draw graphs. I can add another metric. And again, I do the normalized resource consumption. And this time I do the average. And then I get the two of them together. Maybe I want to say, I don't want to do this for all my databases. I only want to do it for its specific database, my ToDoDB. And I can add filters to a graph like this. Or if I just a single line, I can explode it and have one line for each value of database name. And that's called what we call a splitting. So if I remove this one, I can add a splitting. Let's say database name, collection name. Do I have more? And then I get a line for each collection. But in this case, I just have one collection. And I can build graphs like this very quickly and very easily to get insight into things that interest me. But still, building graphs like this every single time is not very satisfactory. So what I can do, I can save it to a dashboard. So I do pin to dashboard. I can create private dashboards just for me, or I can share them with a team. These dashboards in themselves are just resources like any other rules, so identity and access management applies to them as well. Now, let's say I want to store it in this subscription where I don't have any dashboards. So I'm going to create a new one. I'm going to give it the legendary name demo. And I want to publish it to the same resource group. Now my dashboard is created. And let's say I want to create another graph this time. I don't know. Is there something like response times, delay, latency, server-side latency? And I want to get the average and I want to add it to the same dashboard. Demo. There we go. This is why I can build dashboards. And I can access them here at the top left. Open this one up. And this is my previous demo. So let's open this one. And now I have a dashboard. I can edit it, resize things. I can change the timing. I can jump into the graph, change the lines, etc. Now, this is not as sophisticated as some of the dedicated monitoring tools you can get out there. On the other hand, it's free and included with the things you do in Azure. Metrics are retained for 90 days for all services, or 30 days, depending on the service. And usage of the dashboards and the graphs, etc., is free.
I think that relates to a question we have in the chat. Nicoletta asks or writes that I heard that application insights is crazy expensive to the point where a team had to throttle the input to 1%. What is your experience with that?
It's definitely not cheap. If you don't sample your data ingestion, you can get pretty hefty bills, even in cases where your bill for application insights is going to surpass the bill of the actual service you're running. It has to do with the amount of data you ingest. By default, application insights will generate data for a number of situations that we will see in a bit, and you can tune which data you want to gather or not, or you can have a sample size, which you can get down as low as 1%. When you say crazy expensive, keep in mind that it is you should not be looking at that bill of 300 euros every month only, but you should also think about TCO. Because it is going to be cheaper to spin up 2 virtual machines with, I don't know, a terabyte of disk space, or install Elastic Stack, Kibana, and some other tool. I think you always, Elk Stack. And then it feels cheaper. However, if you're going to spend more than 2.5 hours a month on average on patching that system, the total cost of ownership is higher. So it really has to do with calculating TCO and also things like reliability. Do I want to be on call for maintaining my monitoring log system during the weekends? That's the kind of decisions that you have to make. But yes, it is not cheap.
Cool. Thanks.
All right, so that's the things that I wanted to show about the infrastructure level. Let's now go up one level, application insights, and connect it to our application to see which kind of default metrics I can get out of it, and also look at the level on top, how I can use that same installation of application insights in my application to emit custom logs and metrics. So what I've done, I've prepared a small application. It's called logging.monitoring.api. It's a web API tool that has just one controller. So let me open that one up. Zoom in a little bit for you. And what it does, it connects to Cosmos DB. I have container provider, which wraps connecting to the thing. It gets a iLogger of T, which is the default ASP.NET Core iLogger stuff, and it gets a class called telemetry client. And this is a class that comes specifically with application insights. I want to start using those in my code, so I inject them into the constructor using DI, but of course they don't automatically become part of my solution. So what I have to do in my solution, I have to install a package called Microsoft.Application Insights, and if I'm smart, because I'm using ASP.NET Core, I use the specific version for ASP.NET Core. And then you need to be a better person than me and don't use the deprecated version, but use the most recent version, which I think is 2.20. Once the package is installed, I go into my program.cs and I call into a method called add application insights, and dependency injection is wired up for iLogger of T and telemetry client. Once it's there, I can start using it. So let's look at what I can do. The logger is actually very straightforward, and you probably know it from other logger implementations. I say log critical, log debug, log error, and which indicates the level of tracing, and I put in a message. If I want to, add in 1 or 2 values, please don't use string interpolation, because you will generate new types of log messages every time the value changes. Instead, inject a placeholder using curly braces and then specify the value, as you would do for the old-fashioned string.format. This is called structured logging. It will generate one new type of log message and then add the value in a property bag. So you will see both the full message and the message type in application insights in the logs. And this way you can very easily search for other occurrences of the same message. Above this, you also see how I can send custom metrics into application insights. I use my telemetry client, I call into get metric, and then I track a value. If I want, I can also add custom dimensions. So for example, I can do things like get metric, and then my metric identifier is, let's say, field logins. And then I want to add a dimension, and that dimension is username. I say track value, the value is 1, and the dimension value is, I don't know, me. This way, I can very easily get out of my system the total number of field logins, but also the number of field logins for each different value of username. That's the splitting that we saw before. This is basically all I have to do to start collecting stuff out of application insights on the application level. On the level below, with the default application stuff, App Insights automatically collects all the exceptions, which is the reason that I every now and then throw an exception, so I can show that to you. It automatically records all the requests that come in. It gives them a request ID. That request ID is also added to that exception when it is thrown, so you know part of which request it is. The request ID is also added to traces, to custom telemetry, to everything it collects within the scope of that request. And the final thing it collects is a dependency call, which is whenever you make a call into another system, either using HTTP client, but it recognizes, for example, Cosmos client, SQL client, and a lot of default types of clients that you use as well. So this is in a solution. So let's start up the solution. And meanwhile, let's start up Postman, because that takes a while as well. And no, I apologize. I should first mark this back as my startup project. That's what happens when you test things the day before. You shouldn't do that. You should just YOLO your demos. Starting up the web API. Okay, that's running now. I'm now gonna hit my web API. Takes a while because it's going to authenticate to Azure to get a token running on my local machine, and then it's going to actually store the value in Cosmos DB. And in this case, get a number of to-dos. So that works. If I now go back, one of the things that's cool about Application Insights is that it doesn't only work in Azure, where you're paying money. It also works on your local machine where you're not paying any money. So what you see here is that while this was running on my local machine, 30 types of data were collected. 11 calls into a dependency, basically my customers DB, a single request that came in, and a single trace message that I emitted myself. No metric, no page views. This is very specific to front ends, and no exceptions. This works automatically when you install application insights on your local machine. What's cool here is that if I, for example, open this request, so this is a request entry, which you can see right here. It records the URL, etc. I click it, and it automatically opens all the things that are related, which we can see here. So this is the request duration. This is where a dependency call happened, and this is where one. So I can really see how things relate to each other over time. That's the thing that I can see on my local machine, but also when I deploy this into Azure, I can see it there as well. So we will see that in a sec. Because what I didn't just create this web API. I also created a very simple Azure function, which I called loadgen. It's very simple. What it does, it calls into my API every 4 seconds, create a to-do, gets a few to-dos, waits a specific number, and then it waits, until the next occurrences. So this is a continuously running application in Azure. So if we now go to Azure, what I did there was I created a new application insights instance. I go to my research group, logging and monitoring. That instance is right here. It's nothing more than a name when you create it, nothing very special. So when I open it, you will see here at the top that I get an instrumentation key. You have to configure this in your app settings using the name application insights _ instrumentation key in capitals. And then application insights will automatically pick that up when you call into add application insights in your DI configuration. There is also a new approach using connection strings. Then you have to set a setting called application insights _ connection string, top of mind. I haven't worked with that myself yet, but then you use this connection string, which uses localized ingestion endpoints, which is going to be mandatory, I think, in 2025. See that these are not marked as secrets. I highly recommend marking them and treating them as secrets in your own code, because people can start sending shitloads of data to your application insights if the key is leaked. So this instance will be removed after the session. Now all the data that we saw in the local machine is also coming in the cloud application insights where I have my application connected. I can go to the logs, and here I see the logs that are being generated. So for example, one of the things that I can do is requests. I can order them by timestamp descending, which is often the very first query that I run when I'm debugging something. Takes a few seconds the first time. Also because I'm getting millions of records because I didn't specify a take. And what you can see here is that a timestamp is recorded, the ID for the request, the actual URL that's being called, including the verb, the full URL. Everything here is recorded. Data is pretty much denormalized by default, and I can start writing all kinds of queries here. For example, what I can do here is I can get the operation ID, and then let's say I want to find all the dependency calls where the operation ID is the same value. So these are the 3 outgoing dependency calls that were made during that request to my API. Now fiddling with these tables is pretty cool, but it's not always the best way forward when you're trying to diagnose an issue. Now, Application Insights has a lot of added value on top of it, and I want to walk you through a number of the things. One of the things that I really like is called live metrics. So let's go there and see what it does. The reason I like that is when you're using Application Insights, there is a rough 5-minute delay between the time the data is being sent and it's being available in the log store for you to query. That can be a real pain in the backside when you are setting up your logging and monitoring and want to verify if it's working. You change some kind of setting and want to make sure that it's working. Live metrics help you circumvent that. Or maybe you have a very specific problem that happens when somebody presses a button. You open up the live metrics stream, have somebody press the button, and you see things coming on. Traces here on the right, default metrics here. You can even add filters. Sorry. You can say, I don't want to see the traces, and I don't want to only see the field requests and the field dependencies. I want to see all of them. And this will you stream in, and up till a couple thousand entries, this will stay pretty responsive. Another thing that's very cool about Application Insight is that all the information that is ingested is also used to generate some pre-generated views. For example, the application map. What this does is that it will get all your dependency calls from all of your applications and use them to generate a map of how your application is built up. So what you see here is actually my application architecture. I didn't configure this. This is automatically generated. And one of the things that this shows is that my load generator is submitting its log entries to the same Application Insight instance as the Application Insight instance that's being used by my To-Do API. And that's actually a recommended pattern, to not have Application Insight instances all over the place, but have as few as possible. I can now click one of the systems, get details about how it is running, for example, investigate its performance. But a lot of that information is also shown in this graph here. I can see how many calls there is being made, average duration. I can see the dependency calls, again, the average duration, the amount, etc. What's interesting here is what's happening with the calls into Cosmos DB. It's saying, hey, you're not just doing one type of call, you're actually doing 3 types of calls. So I can expand this group. And then for some reason, it's just showing me one of them. So let's do last 24 hours. Not too bad. We get 2, not 3. But here I see that one type of call is successfully working like all the time. And it's taking very, very long. Cosmos DB should have very quick responses. But if we dive into this, we will see that these are so-called metadata calls connecting to the container. These are the calls to my actual document store, and they are well below the 10 millisecond mark, which is cool. And I can drill down into this, and then I see that 0.1% is failing. So 1 in every 1,000 requests, more or less. And that's because there are exceptions being thrown in 1 in 1,000 calls. That's correct. If we go back to my code, to my to-do controller, you see that roughly 1 in 1,000 calls, I will throw an exception. Now we can drill down here, but I kind of want to show you this as well. If I click failures, what I see is a timeline of all the failures happening over time. I see the calls here that give the most failures. They are ordered, the total number of calls, the number of failed calls. And if I click them, in this case, for example, creating a to-do, I see the invalid operation exception. And then I see all the requests that generated such a request. And then I can click them, and I will get into a full breakdown of what has been happening during the execution of that request. And again, here, it doesn't just focus on the application that I'm investigating. It shows me both applications and that I'm interacting with. You see, first my load generator, then my to-do API, and then something within my to-do API. So it implements what we call distributed direct tracing by default. I didn't do anything to do this. And this even goes so far. For example, if you call into another system that also uses Application Insights, you might even see a line here saying that you don't have access to the telemetry of that Application Insights instance. That are just some of the goodies that I wanted to show. There are many more. Let's do one more. For example, there is a search option. This is very much like Elasticsearch. I can just type in something, and then I will search in everything, in all the traces, in all the requests, in all the dependencies. So if somebody says I'm calling a specific API, and I don't really know where I logged that, I can just quickly search in everything. And please observe how blazing fast this is. I'm searching through 24 hours of data, and it's our sub-second responses. As there were a lot of questions regarding the pricing and how you can tune that, I want to give you one more tip to keep the cost of logging down. What you can do is you can if Visual Studio is working. Thank you very much. You can go into your app settings, and here you can configure the amount of logs that you want to send. And by default, this is often configured to information. But what you can do is you can specify namespaces, fully qualified namespaces, for which you want to separately set the amount of log entry that you generate. So for example, if you are using a lot of classes by Microsoft that also generate logs, but you're not really interested in them, here you can say error. Only messages error and critical from any class for which the fully qualified name starts with Azure are going to be sent. So I want to do that here as well. You know what? For my own stuff, I'm going to put this on warning as well. But now I know that there are some issues with Henry Bain, logging, monitoring, some namespace. This one I want to put to trace. These settings you can update from your configuration, either in the portal or using your infrastructure as code. And this way you can tweak the amount of logging that's being gathered on the use case that you're currently working with. You can also use adaptive sampling, which allows you to say, hey, don't record all the telemetry, but just 30% or 40 or 1. And it can even be adaptive. Then it scales down to 1% when everything is running fine. But as soon as errors start up, it will up that percentage of data that is being gathered. And finally, one of the things that you can do, and I think should do, is you can configure the maximum amount of money that you're willing to pay for application insights. And whenever that cap is reached, it will stop ingesting new log entries. And that's a great way to guard against a new type of attack, I believe we will see, which is not a DDoS on the availability on your system, but a DDoS on your purse. So that in response to the questions that came in here. That being said, and with 3 minutes on the clock, I kind of want to wrap up. But there are two more things. First of all, this demo, it is not on GitHub yet. It will be there somewhere next week. It has the infrastructure as code for the demo. It has the binaries for the to-do API and the load generator. So with those two, within 5 minutes, you should be able to spin up your own constantly running demo, which helps you to play with the different features of application insights. Just be wary, it will cost you money. And the second thing is dashboards and alerts and metrics, all the diagnostic settings, all the things I've shown you, they are all configurable as code using ARM templates or Azure Bicep. So don't do what I did. Don't go clicking around in the portal, but do this in a proper DevOps way. And hopefully I do want to encourage you to try this at home. Are there any final questions?
Yes. Well, first off, thank you for the presentation. That was really great. So there was a few questions related to the last part of your presentation. So in relation to application insights, is it recommended for front-end app and back-end APIs to use separate instances, else the application map becomes a mess? I guess
I feel very reluctant to comment on that because I think it's been 15 years since I created a front-end application. So I have no experience with this. I'm sorry.
All right, that's fair enough. Then there's another one. Is there a system-generated correlation ID for end-to-end tracing?
It is generated, yes. It's auto-generated to correlate the things together. Now, I must not tell lies. I know it is possible to. It's always very, very difficult to say something with a very firm opinion. To the best of my knowledge, it is possible to implement distributed tracing using application insights because there is an open standard for distributed tracing. And as far as I know, you can implement that standard using application insights. Now, the things that I showed, application insights, connecting everything together, I'm not very sure if that is done using a auto-generated correlation ID or if it's derived from the dependency calls that are being registered. So I have to be a little bit careful of what I say there?
Yeah, I think that was it for questions. So Alan just wrote in the chat that he recommends separate your app insights spaces, and you can combine them later if you decide to.
Yes, you can of course combine them later. You can also separate them out later. What I have seen, especially when teams start generating microservice architectures or multiple APIs that are very closely related, and they start having 10, 20, 30 different application insight instances, one connected to each API, it becomes nearly impossible to troubleshoot queries of issues very quickly, because the queries become very complicated. And there are ways to pull in data from different log analytics workspaces into one log analytics workspace, but I have no experience with that as well. I found that just putting everything together was the best way forward for us.
Yeah, and I guess that relates to the question on whether KQL can query across multiple application insight instances.
There's a lot of these things that are possible, and I can only tell you about my experiences as a developer. So I spent as little time as possible. It sounds very negative, but I try to limit the time that I spend on this. And in my experience, going for the simplest solution saved us a lot of time. And especially when you start creating distributed architectures, having tens or hundreds of very similar things spread all around is not always the best strategy. But that is my recommendation, my experience. That's a very good question. I don't think it is deprecated or anything. I know there have been even features added last couple of years. But I think it is more focused on mobile applications right now. But it is out of my comfort zone.
Yeah, makes sense. Yeah, well, I guess that's it from questions from the chat. Well, I guess I can ask my own question. But there was another Morten who asked that it's available for Rider. So I think I'll go find that afterwards.
Yes, I really like Visual Studio proper, so I can't answer that question.
You're the real Visual Studio crowd.
Yes, there. Yeah, I don't want to get into a flame war there, but
No.
somebody coined Visual Studio proper, and that really stuck with me.
Yeah, but it's pretty cool. I mean, I hadn't actually seen that extension was available to Visual Studio, and what you showed looks quite useful.
And it's real time,
yeah,
so you don't
yeah.
have that 5-minute delay that you have when you use the real application insights.
Yeah, I can see that being super useful in scenarios where you're trying it out and seeing what does this block of code actually generate, and is it useful from the perspective of looking it up in application insights afterwards. So that's pretty cool.
I see somebody asking if it doesn't use trace identifier from the HTTP context. It might be. I'm just not sure, because there is so much happening in this space, and I haven't done anything with distributed tracing for almost 2 years. And there are different tools, different standards. I don't want to say something that's wrong. I rather say I don't know than have something on the internet that's not correct. There's enough on the internet that's wrong, so let's try to not add to that.
Yeah. Cool. All right. Well, I think that's it for now. We're also at the hour, so I'll just add these slides again because we have a little word from our sponsors, since Microsoft Denmark helps us supporting these meetups by providing the streaming platform. So of course we're quite happy with that. Microsoft Denmark has this initiative called Azure Heroes. I think it's in Scandinavia, maybe even across Europe. But you can join it on aka.ms/azure.heroes. And what you can do is collect these badges. So whenever you attend a meetup or potentially a conference, when we get back into real proper conferences in person, you can scan QR codes, collect these badges. And then I think the point is that you at some point can exchange them for swag. And I know they added something where if you add yourself to the map, they would randomly pick out people who has badges and send them a little surprise. So I just want to show this badge so you can snap this one for this meetup and then use it on this website. So yeah, I guess that's it for now. So thank you again, Henry, so much for taking time out to talk with us during this lunch session. I think there was a lot of great questions, a lot of great interaction in the chat. So that's good to see. And I think we'll be back in April with the next one. So keep an eye on our meetup page, and I'm sure something will be announced very soon. So with that, thank you for joining us. See you next time.
Thank you for having me. Have a great one.